Okay, welcome to today's webinar on getting your IBM Z data into AI in hours, not weeks or months. And we'll talk a little bit about that experience that we hear from a number of customers that we interact with. I am Dustin Froyam and one of the co-founders of VirtualZ Computing. And today I have Vince Ray, our CTO and co-founder, co-presenting with me. Hi, Vince.
Morning, Dusty. Hope looking forward to this one. It sounds like we have a good crew out there joining us today.
Hopefully we get some good interaction and questions. That always makes it more fun.
Yep.
So let me go through a little bit of the agenda. We did the intros. So we'll talk a little bit about the challenge with legacy ETL. And I don't know, Vince, one of the things we've come across a lot lately is really complex change data capture just to get mainframe data to a target, either for a database or AI or BI. So we'll talk a little bit about that. And Vince will talk us through a little bit about the architecture, sources and targets. And we'll talk a little bit about, throughout this time, what makes PropelZ really differentiated in the market, and to make things really easy to get that data out of your Z platform for other purposes. And then we'll have Q&A, and I'll talk a little bit about some other resources, and we'll wrap it up. So I think, those of us that have been around the mainframe world for a while, or even if you're new, right, this is a really big market that's going on right now with the hybridization of the mainframe. And as we know, a lot of critical business data still remains on the mainframe. I see up to 70 and 80% depending on the survey that you look at around that. But some customers and companies are moving off the mainframe, but many are not, right? That is still the core of their enterprise. And so they're maintaining that, and because of the efficiency and the security, but they need to share that data in a more efficient fashion. And that's what we'll kind of address here today. I think this won't be any surprise to those, again, operating into the mainframe area of the world. So you have kind of escalating costs for a number of different reasons, but everyone is really conscious of their resource utilization on their mainframe, and making sure that the capacity that you are using is going through value added work versus stuff like just classic ETL. We see companies up to 40% of just their general processing capacity being used for ETL purposes, which is, that's a lot for and very costly just to share some of your data out of your mainframe. Talent challenges, as we all know, complex integrations, right? The mainframe has a different architecture, data formats. And so how do you simply share that and move that data around to do that? And then obviously with the dawn of AI and modernization, you don't want to have a segregated, oh, here's my mainframe AI or BI and reporting or data lake. You want to have that truly integrated. And so, how do you do that in an easy fashion? So Vince, let's just talk a little bit about the architecture of PropelZ, and then we'll kind of go into what makes that really different and easy to use and implement for a customer.
Yeah, no, well, first of all, thanks for the good intro and lead into this. PropelZ is, the way I think of it is it's basically replication from just about any mainframe data source to any target. Now, the way this works is, we think of PropelZ as three parts. There's an input stage, a processing stage, and an output stage. The input stage, typically what customers are using PropelZ for is stuff like, VSAM files or, sequential files that you might have on your mainframe. And these are usually the most problematic things out there because they're complicated. They're for historic reasons, they're very kind of unique to the mainframe in terms of the data formats, and there are all sorts of issues trying to understand what's in these types of files. So PropelZ gives you an easy way of doing that. It can ingest that kind of data. You can supply a little bit of metadata to tell us, don't treat this record as a blob. It's got a couple of fields that are text. And by the way, they're encoded in EBCDIC format. They need to be converted to UTF-8 or ASCII or whatever you need. You might have other fields in that record that are floating point values and mainframe style floating point numbers. It might be packed decimal. There are all sorts of complexities to understanding that data. So you point to the data, you give us a little bit of metadata, and we can understand that as Dusty says, with no coding, nothing that you have to do other than point us to the data that I'm talking about. The metadata can be, it can actually be a few things, but the simplest thing is, most mainframe sites are going to have things like COBOL-copybooks that describe those records. You can just give us that, and we can infer the structure of the data based on that. So that's one category. And while we're talking about inputs, we're not limited to the VSAM files or sequential files. We actually can work with just about anything. So an example of that, and you'll see a demo of this on our website. We wanted to create a solution where we take live ZOS systems management data, console messages, that type of thing, and pipe it through PropelZ to populate data into a product like Splunk. And in that case, there's no VSAM file, there's no sequential file. What we've done is we've just ingested data from, in this case, it happens to be a program source. We had a little application that knows how to read console message traffic in real time, and that gets piped into PropelZ as an alternative to using things like VSAM files. So really, it truly is any source. If you had a CICS transaction or a batch job or whatever you want to be the source of data into PropelZ, we can work with all of that. In the processing end, I mean, a lot of that is what I described so far. It's understanding the structure of the data. And, that can be, really simple. I mean, you might have an application that knows how to process that data bit for bit, and, you don't want it transformed in any way. But if you do want to do something like convert it into rows and columns for storage in a database, then that's where that kind of central phase comes in. So, and again, that's largely understanding the input data we've been given, understanding what target or plural targets we want to go to, and transforming the data so that it's appropriate for the target. An example of that is if I have a numeric field, the way I express that on different database targets might be slightly different. Just in, if I'm going to a SQL database, if I'm going to a MySQL or an Oracle or wherever it happens to be, the syntax for how do I structure a binary field or a numeric field or a floating point field might all be a little bit different depending on what that target can handle. So all of that's handled in the processing part of PropelZ here. And just as I described for the metadata, all of that is achieved without coding. Everything we do is defined by nothing more than a couple of configuration files. And the beauty of that is if you want to take your data someplace that we don't support, I mean, certainly you can work with us and we'll do that work for you. But if you have some reason that you want to do it on your own, or whatever your needs are, you're more than welcome to do that. And again, that's not writing code. That's creating configuration files that define the data types and what to do with it. On the output side, uh, which is really the kind of endpoint of Propels, again, there's some flexibility there. The most common thing is that it's going to be, a target that supports JDBC. And, JDBC is an industry standard for talking to things that sort of look like databases. There are probably 100 different database products that have JDBC support. We build in some of them, but it's, as I said, it's really open-ended. With the right configuration data, you could connect to really just about anything in that JDBC universe. And what that means, and the reason we do it that way is because that's a really efficient protocol. Where some of the things that compete with us, transfer your data to another platform somewhere, run some code on that other platform. So it's multiple hops. It's multiple move the data around through different components to get to the target. In our case, it's direct. It's read the data from whatever source, transform it as it needs to be for that target, and then write to the target, all done directly from ZOS. So very low overhead. We're using protocols like JDBC that I mentioned that are efficient, they're binary, they're designed for moving lots of data back and forth in and out of databases. So it's it leaves us with a very efficient and high performance solution here. Now, just as I mentioned on the input side, I mean, the JDBC universe that I talked about is the most common thing, but it actually is open-ended. You could go to lots of different things. I mentioned that we created a solution around Splunk. Well, in that case, we're not using JDBC to talk to Splunk. We're essentially calling an API to populate that data into Splunk. So again, if you go down that path, the the data that you can get out of Propels is, I mean, again, it could be bit for bit what we read from that original, let's say VSAM file, but it can also be transformed into JSON objects or XML objects or CSV or whatever you might need there. So, you can have that data in whatever format is easiest to push it to the target that you want. If it's JDBC you're using, you never see any of that. You just tell us, here's the database I want to go to, here's the JDBC driver that knows how to talk to it, and the rest is transparent. If you need to do things like, gee, I want to take this data and drive an API with it, then you might look at it and say, well, give it to me as a JSON object, and I'll push it forward from there. So, end to end, that's kind of the Propel story. One other, key point that I'll make is that, and Dusty touched on this, everybody's sensitive about uh, processor utilization on their mainframe. So we've been careful to architect Propel so that it's eligible for execution on an IBM specialty engine, a zIIP processor in our case. So what that means is you run all the Propels that you want, and it's not going to influence your software costs for all of the things that you might be doing on a capacity-based license with IBM or other vendors. So really key point, it's not just that it all runs on the mainframe, it runs inexpensively on the mainframe. So Dusty, what did I forget to mention that I should have mentioned?
No, I think you covered a lot. I did have a kind of a couple questions. So Vince, given that architecture, right, with Propels runs on the mainframe, the drivers run on the mainframe, and then it's codeless on the target side. Can you just talk about um, what we support kind of with our package. You kind of talked about it, right? We can plug and play a lot of different things, but we do have some out of the box items, right?
Yeah, so kind of working backwards on the targets, we package up 5 that I would call certified and ready to go. So it's MySQL, it's Microsoft SQL Server, it's Oracle, um, it's Postgres, and it's Snowflake. Those 5 are kind of bundled in with PropelZ, and that means the configuration data is ready to go. That means the JDBC drivers are included in the package. Uh, it's truly just point your data, tell us one of those 5 supported targets. You need to supply, credentials and host names and that stuff, but nothing really more than that. Beyond those 5, as I said, almost anything is possible. So certainly, if you need something outside of those 5, talk to us, and we'll see what we can work out for it.
Yeah. So Vince, thank you for covering that. Can you just talk a little bit about, you and I have had several conversations in a couple different veins, right? So one is, customers have spent, in some cases up to 2 years trying to implement a very complex change data capture um, architecture to just get their data shared outside of the mainframe. And part of that was they wanted to share it intraday, not even update the mainframe itself, but just to share the data intraday. Can you just talk a little bit about what we can do on that, both in your online window or batch, and kind of the ease of use um, that we have available?
Yeah, and that's a really great point, because we do. I think of it as incremental processing. That's very different than the change data capture model. So with the change data capture model, what usually uh, challenges most customers is that the idea is that I have a mainframe application that updates a file, and right in line with that update, it somehow gets captured, and synchronously that change gets applied to the target system, whatever that is. The problem with that is it's super complicated to do that. It can be slow. It can require changes to your operational environment. You have to, frequently have to turn on VSAM logging and all sorts of other things to use, journaling for these files so that the CDC solution can work. And of course, when some piece of that chain breaks, it can be really difficult to diagnose and fix what the problem was. Was it a network error? Did I run out of space on my Oracle database? What's the issue there? So, and as you said, I mean, I'll just second what you said. I mean, customers absolutely have told us, hey, we've been working on this for 2 years and we don't feel good about the solution we're getting. So we took a different approach. Our approach is, first of all, we want to recognize that there are really very few cases where you need that level of transactional integrity, where you have to be able to guarantee that when I write to, let's say, a mainframe VSAM file, an Oracle database is updated in that same transactional context. If we go back to the customer and say, that change will get there, but it might be asynchronous. It might take 5 seconds or 5 minutes, or whatever you need. Uh, most of the folks we talk to are perfectly good with that, because most people aren't writing these multi-platform transactions that join data between, a VSAM file and an Oracle database, for instance, in my example there. So if your requirement isn't to have that kind of true real time with full transactional integrity, why would you want to absorb all the cost and overhead of that? So what we do is a little different than that. What we do is an asynchronous process. You run PropelZ ask it to monitor a particular file. And, you know, and you can do whatever interval you like. If you want it to be seconds, fine, we can do seconds. If you need it to be every hour or whatever you need, it works. And then what we do is we have a way that we can examine that file, figure out what's changed in the file, and then propagate those changes to the target. So, you know, the source and the target will stay exactly synchronized. So, you know, if I log on to my mainframe and I delete a record out of a VSAM file, I'll see it deleted out of the target. The only difference is that in our case, that's done in an asynchronous way. Now, the benefit of that is you don't need to change your operational environment, right? You don't need VSAM logging. You don't need all that other infrastructure that goes with it. You don't need to slow down your transactions that are doing updates to wait for these uh, CDC flows to occur. You know, it happens completely outside of that. And if it runs in 3 seconds or 6 seconds, it's generally not an impact to anything. Your existing transactions that are doing these updates continue at, you know, full speed with no interference at all by Propels. It's also self-healing. You know, something goes wrong. If there's a network glitch, well, fix the network glitch, and the next time that synchronization process runs, uh, all of the updates will be reconciled at that point. So you never stand a chance of losing anything. Might be out of date for minutes or, you know, however long it takes you to fix the network glitch in my example, but it doesn't stop anything from running. And, you know, again, this is we find that a lot of customers are taking snapshots of the mainframe data and using it in AI applications or some other type of application, but it's essentially an analytics or uh, you know, a reporting need or you know, intelligence need. It's not necessarily that you're trying to drive, you know, live transactions that way that are trying to update data all over the place. So, you know, again, our idea is a little bit different than what you see in a CDC solution. If you're and you know, at least 80% of the customers we talk to are, you know, once they understand that and what the trade-offs are, I think most of them are happy to go with the, you know, more asynchronous process that Propels offers versus you know, some of the others. Was I clear on that, Dusty, or is that
Yeah.
parts I
Um,
skipped over?
yeah, and we've got a question, but I just want to just make a couple points. So, you know, there is a there is a efficiency to using Propel. So all of our installs happen, the installs literally happen in minutes. And in most cases, people are moving data um, within, you know, an hour, a couple hours. And that really has to do with the configuration of the JDBC driver. If you're bringing your own, if you're using ours, it's, you know, it's even faster. And Vince recorded a demo. Literally, that was it's about an 8-minute demo, but the whole from install of Propels, moving a complex VSAM file to the rows and columns of a MySQL database, and then actually presenting that data in Tableau under an hour of real elapsed time. And that's very consistent with you know, everyone that's installed Propels and using Propels today as well. So, you know, that's a big difference in how that experience goes compared to some of the other solutions, or having to do your own ETL process besides some of the other advantages. I did want to mention before we go into some questions here, Propels is a flat rate of $50,000 per year, and that includes all of those drivers that Vince mentioned. And again, we can test and configure additional drivers. Typically, that's $5,000 to $10,000 for an incremental driver, so it's not a very much. It's not very much money to actually do that. So, when you compare this to some of the other ETL, like off-the-shelf ETL solutions or change data capture, it's an extremely cost-effective solution besides the general processing savings from zIIP eligibility. So, Vince, we did have one question in the chat that I'll start with. And I think we covered this, but I just want to make sure it's clear. Do we need to install any agent or anything of that sort on the mainframe?
Well, PropelZ itself is installed on the mainframe. PropelZ is mainframe application. It can run a variety of different ways, JCL or batch or interactively at the command line. There are a lot of ways it could be run, but it is mainframe software. The strength we have is that we have no software off of the mainframe. So it's not like you have to have a Windows or a Linux tier or code at the whatever target you're going to. There's nothing there, and that's what makes it so easy to go to lots of different targets at the same time. It's we just assume that the target is something we can talk to either through JDBC or in an API way or whatever it is, and that makes it much easier to be kind of agnostic on what the targets are. The other thing too, I'll just, and I think this is probably a little bit off topic, but many times the model that you see is that you have let's say batch jobs on your mainframe that create files, and you want those files to be replicated out into the cloud in a target that I'm describing in PropelZ. So a really, really simple way to integrate with that kind of process is you just add a step at the end of that batch job that runs PropelZ for you. And so, your batch job runs, it creates the data it needs to run to create, gets fed into PropelZ. And when that batch job is complete, now you have the most latest up-to-date information out in whatever targets you need it to be in. And many times we hear that the customer needs to go different places with the data. It might be that you go to Snowflake for some AI work. Maybe you go to, I don't know, Oracle or SQL Server for God knows what other reasons. So again, we support that kind of thing pretty cleanly. It's like, where do I need this data to go? And in that example of integrated with the batch process, that's like the best of all worlds. There's no CDC running, consuming MIPS, any of that stuff. It just runs with the rest of your workload as as though it's not even there. And when it's done, your data is where you want it to be.
So the next question is, and Vince, this is an interesting one because it's actually been coming up quite frequently. Does this support data on iSeries?
Yeah, so if you have a mainframe in your environment that can run PropelZ, then yes, it turns out there actually are ways that you can ingest data, the input data from, let's say an iSeries platform. The part that you can't do, at least today, is you can't run PropelZ itself on your iSeries system. You would need a mainframe environment, and then we can access the iSeries data over, a network connection. If that's what you're looking for, if you really want a iSeries native version of PropelZ, that's something, as Dusty said, we've heard this requirement a few times now. And, I would encourage you to talk to us because, frankly, it's not a hard thing for us to do. We just didn't recognize that there was a business case to be made for that. So if you have those requirements and it's something you'd consider working with us on, it is definitely something we are capable of delivering.
Yeah, thanks, Vince. That's exactly what the point I wanted to make as well. So, we are talking with a couple other partners about this need, but we'd welcome a discussion on that if it's really important that it run actually on iSeries. Vince, I wanted to ask about performance a little bit, because I think that's another distinguishing factor, and really, we've talked a little bit about how do we do incremental updates and intraday updates, but can you just talk a little bit about the performance?
Yeah, so performance is one of our strong spots, and we do that in a few ways. I mentioned some of it before. We use efficient binary protocols that are optimized for moving database data around. Within that, we also optimize for JDBC and things like bulk inserts and batching lots of queries together. It might be the case that we're certainly not going to do insert a record and then commit that change to the database and then do the next record. We might insert literally thousands of records and then do single commit. It depends on a bunch of different factors what's optimum, but the idea is we do all of that. So to kind of put some concrete numbers to it, understand that my development environment isn't what I would think of as a real mainframe. I have an IBM Z PDT system. For those of you who don't know what that is, it's ZOS running on an Intel-based Linux server. So smallest mainframe you could possibly get. It's well under 100 MSUs. So I have that. I have consumer grade gigabit Ethernet, and I have targets that are generally running in the Amazon free tier. So we're talking really tiny databases that are on the receiving end, and we're talking networks that are pretty small too. So one of our standard tests, and it's the data Dusty referenced before that we use in many of the demos. It's a mainframe VSAM file that has a record for every one of the world's airports. And for every airport, it has the names and various codes and elevations and altitudes and latitudes and longitudes and all sorts of things. So it's a big record. It's 1,000 bytes of data for every airport in the world. It works out to some just about 80,000 records in this file. So what we see, if I just as an example, look at one of the benchmarks we run in our environment, and keep in mind it's as I said, it's this probably the smallest possible mainframe environment. We see 6,000 to 8,000 rows per second going to a Postgres database. And honestly, most of the databases we support are pretty close to that. Some might be a little better, some might be a little worse, but they're right in that range. Our feeling is that a serious mainframe customer with a medium to large mainframe and serious networking connecting to whatever target he wants should have no trouble doing at least 10 times that amount of throughput. So I could easily see hundreds of thousands of rows per second in a heavily optimized environment, or an environment where maybe the target's not in the cloud, maybe the target's on a database server in your own network, for instance. There you might have a huge amount of network bandwidth between the mainframe and that target, and that probably gives you the kind of processing we're talking about. The other thing that I'll mention too is that in that benchmark run I described, about 96% of the MIPS capacity that we use on ZOS is dispatched on a zip engine. So, very, very little kind of spills over onto, much more expensive general purpose MIPS. And the other thing I wanted to mention is that even in that, you know, small environment that I'm talking about, uh, we don't use more than about 5 to 10% of a single CPU processor engine on the mainframe side. So a very small amount of actual MIPS being used here. And you know, if you have that question, we are using all of the features that I described there. You know, we're using metadata that started out as a COBOL copybook that described our records. The records have some of every possible data type, from EBCDIC text to floating point to packed decimal, and so on and so on and so on. We have if I remember correctly, there are about 40 different fields in that record. So it's not just like a couple of different fields and you know, teeny little records. These are, you know, 1,000 bytes long with 40 fields to them. So, you know, there is quite a bit of processing going on there. It's just that it's, you know, so streamlined and efficient. We're able to do it at a, you know, pretty significant clip, you know, even in our teeny little environment that I'm sure, you know, no one on the call would have any trouble, you know, beating those numbers to to death compared to what we get.
Hey, Vince, we got another question. So another one of our favorites. So the scenario is IMS source data, right? IMS DB, one of our favorites, and then Postgres DB, specifically in this instance in Amazon Cloud. So yes, on Postgres, that is, yeah, it has a JDBC driver. So bring your own JDBC driver or use ours out of the box. That's already optimized. So yeah, Postgres is definitely a supported target. Vince, you want to talk a little bit about IMS?
Yeah, so the IMS answer sort of depends on what you have and, you know, the versions of IMS and which optional features you license. You know, many customers have the IBM Z enterprise tools that come with IMS, and one of the things that's in that package is what amounts to a JDBC input interface to IMS, and in that case we absolutely can use that to read the IMS environment. It comes to us as though it's you know, basically a database table, and then we go through Propel's processing and push it as, you know, as Dusty described. So, you know, that's probably the best case. There's nothing particularly custom that needs to be done there. But it doesn't have to be that. I mean, it you know, if you have a favorite, you know, reporting tool or just about anything else that's accessing IMS for you, you know, we can generally work with that as well. And then, you know, instead of producing, you know, let's say printed output or something like that, you do the query you want to do in the tool of your choice, pipe that into Propels, and then that's where we get the data to actually push it to the target. That way, you know, you stay in complete control of all of that. There's nothing new that needs to be built there, and you just kind of leverage the tools that you've got already. You know, many of our customers will use something like SAS or EasyTrieve or really tool of your choice to access IMS that way. And then the data that comes through there is what will ultimately push to you know, whatever targets you like. So yes, I mean, that's a perfect example of, you know, we don't really care what that input is. I mean, we could replace IMS with, I don't know, ADABase or IDMS or Datacom or any of those other things that you tend to find on the mainframe, and they would sort of all follow that same kind of pattern. And again, it's something we'd be happy to go into more depth and, you know, discuss with you if you have a real need there. We're happy to, you know, drill into that, and we can help with that in really any way that's needed.
Right, I'm not seeing any other questions. We've covered a lot here. I will double check one more time before we conclude. just mention PropelZ is just one of our products. Lozen does actual real-time read-write. So back to your mainframe as the system of record. So really getting rid of, again, all of those complex change data capture. So that's a really interesting and powerful tool. And then ZAC is, the mainframe is the client, particularly ZAC allowing you to access cloud and SAN storage as if it were virtual disk or virtual tape. And you can do that in different in different architectures or different manners, right? So and simultaneously. So think about having a copy of your data and using Amazon Glacier as your tape archive, your virtual tape library, or even a tertiary copy. Or actually, you can live process against a DB2 table or a VSAM file on your SAN, saving you DASD resources. So lots of really cool capabilities there. PropelZ has a ton of other use cases, and you can find a lot of those in our blogs and our demos. Vince talked a little bit about one of those with like mainframe management data into Splunk. So that's a pretty cool one. But we have blogs. Each of the products has other demos on demand. And then, yeah, if you'd like to reach out to us about any of the things you've heard or some of these other products to brief, please do that. And you can reach us at hello@virtualzcomputing.com, or Vince or I hit us up on LinkedIn. We'll be glad to connect with you. All right. Any final questions? I'm not seeing any, so we'll close it out. Thanks, Vince, for all the great information and for everyone for joining us today. Have a great rest of your day.